In this module, I want to go through Newton's first law of motion, which is a force is needed to change velocity. In other words, a body will stay still or move in a straight line at a constant speed unless there is a resultant force acting on it. A television on a table won't go anywhere because the forces acting on it are balanced. Newton's second law of motion is acceleration is proportional to the force, and that's where it comes out here, F equals ma, where F is the force in newtons, mass is the mass in kilograms, and A is acceleration. Consider two balls of different weight being dropped at the same time. If you did, then ignoring air resistance, they would hit the ground at the same time. This is because the only force acting on the body is gravity, and this is constant, it's 9.81. In other words, the acceleration is independent of the mass. The best way to explain this is to look at the formula that determines the force exerted on a body due to gravity, F equals ma. Now if we transpose this, we get A equals F divided by m, yeah? A equals F divided by m. Right, let's have a ball weighing 100 kilograms and a ball weighing 1 kilogram. What is the acceleration of the 100 kilogram ball if you drop it out of a plane? Well, the force due to gravity on the 100 kilogram ball is 9.81 times 100 is 981 newtons. So that's the force of gravity acting on the ball. Put this in the formula, the 100 kilogram ball will accelerate at a rate of 9.81 metres a second squared. What's the acceleration of the 1 kilogram ball if you drop it out of a plane? Well, the force due to gravity on the 1 kilogram ball is 9.81 newtons. You put this in the formula, you get the same. Do you understand? It's immaterial because the force acting on it is dependent on its mass and the acceleration, but you divide it out by the acceleration. That's why everything, you drop them out, ignoring air resistance, it will accelerate the same. So do you see, everything's planet will accelerate at the same speed. It's the force acting upon it due to air resistance that caused the difference in the actual speed. What is Newton's third law of motion? Each force has an equal opposite reaction force. In other words, if an object A exerts a force on object B, then object B exerts an equal and opposite force on object A. For example, if you push against a wall, the wall actually pushes back against you just as hard. Yeah, it's pushing back, there's a force on it. As soon as you stop pushing, so does the wall. It's got weird, isn't it, this? If you push against a wall, there's a force off that wall, stopping you. If it didn't, you'd move the wall, wouldn't you? You'd move the wall and fall over. So that's why if you push a force there, that's got to put a force back on you. If you pull a trailer with a length of rope, whatever force you exert on that rope, the rope exerts the exact opposite pull on you, unless, obviously, it's stretching. Now, Newton's third law of motion applies in all situations and to all types of forces, but the pair of forces are always the same type. Yeah? It depends on the situation, but the pair of forces have got to be the same type. Let's think of the forces acting on a parachute. The force acting on the parachute are initially weight due to the forces of gravity. It will experience some other forces due to drag, obviously, and air resistance, won't it? It will. Now, there comes a point where the parachute will reach terminal velocity and the body will not accelerate anymore, won't it? So basically, as it's coming down, it's got weight on the parachute, it's coming down, the guy jumps out with a parachute, it's going to travel, it's going to accelerate. However, it's got a force pushing up, air resistance now comes up, and when there comes a point when the parachute will stop and it reaches terminal velocity, and this is when the forces are balanced now, it's not going to get any more acceleration. Let's do an example. A narrowboat is moving across a river. The engines provide a force of 500 newtons at right angles to the flow of the river. The boat experiences a drag of 100 newtons in the opposite direction. Now, the force on the boat due to the flow of the river is 300 newtons, and the mass of the boat is 250 kilograms. What is the resultant force acting on the boat? And B, calculate the acceleration on that boat. Okay? Well, as you can see here, the perpendicular forces will be 500 newtons minus 100, so a resultant force of 400 newtons. Now, if the river is exerting a force of 300 newtons, as you can see here, you can use Pythagoras' theory to determine the resultant force. And it's a squared plus b squared equals c squared. And therefore, you put that out, you get c equals 500. 500. So the resultant force is actually 500 newtons. That's the resultant force. Now we'll determine the acceleration of the boat using this formula here. F equals ma, force equals mass times acceleration. Now transpose it, we get A equals F divided by m. Well, that gives us out 500 divided by 250. It gives us an acceleration of 2 metres a second. So that boat, that there will be accelerating at 2 metres a second.